Swayam Prabha. Digital India. Educated India.
Welcome back to lecture number 13, part 2. I will be continuing the portion from where I have stopped in the previous lecture, part 1. So, if we recollect, I was explaining about the balancing of the what happens to the forces. There are 4 forces which are acting on the automatic expansion valve. One is the force due to the adjustment spring. Another one is the atmospheric pressure. Both act in the same direction. And in the downward direction, 2 or more forces act, that is force due to follow-up spring and evaporator pressure. So, if you see the first case, when the load increases, so we are seeing the summation of the force due to adjustment spring and atmospheric pressure is less than sum of the forces due to follow-up spring and evaporator pressure. When PAS plus PA is less than the sum of force due to follow-up spring and evaporator pressure, that is this condition. So, the needle will be towards the orifice. The needle will move towards the orifice, thereby making the valve opening narrower. It is not wider opening, it is narrower. The valve is, it's slowly the opening position gets reduced and it is about to close. Valve opening becomes narrow valve opening. Valve opening becomes narrower. That is valve about to close. About to close. So, this is when the load increases. Continued from previous page, when load increases. So, due to this, less amount of refrigerant flows from the expansion device to the evaporator. Therefore, mass flow rate of the refrigerant decreases and there is less mass flow rate of refrigerant to the evaporator than the amount of refrigerant that is drawn by the compressor. Starving of evaporator will take place. So, that is, this means the mass flow of the refrigerant in the evaporator is less than the mass flow of the refrigerant in the compressor. Then this lead to starving issues in evaporator, like similar to the what we have seen in the capillary. When the load decreases, let us go to the previous. This is when the load decreases. This force PF, the summation of the forces acting in the upward direction is more than this one. So, this can be written as PFS PAS plus PA is greater than, here it is less than, okay, when the load increases, this is less than, here it is greater than PFS plus PE. So, the needle will will be away from the orifice, from the orifice. Let us go to the diagram. When the combination of the forces acting on the upward direction, if these two are more than the downward forces, then the needle will be away from the orifice. That is, the valve opening is broader. Valve is opening as it is opening, just opposite to the other case when the load decreases. So, needle will be away from the orifice and the valve opening becomes broader, and the valve opening is broader. Valve is open. Valve is open. Under this condition, the more refrigerant flows to the evaporator from the expansion device. So, the refrigerant mass flow rate increases. This means mass flow rate of the refrigerant, let me write, capital E is evaporator. In the evaporator is more than mass flow rate of the refrigerant in the compressor. So, evaporator is flooded. Evaporator, under this condition, evaporator is flooded with liquid refrigerant. So, here also critical charge have to be used to avoid starving issues in the evaporator and flooding issues in the evaporator. What happens when the evaporator is flooded with refrigerant? As it gets accumulated, it will overflow, and there are chances that the liquid refrigerant will enter the compressor, and it causes slugging issues in the compressor. The compressors are designed for handling gases and vapors and not for handling liquids. Let us see the salient features. The simple design, it is also economical, but it is not as cheap as the capillary tube. It is employed in home freezers and small commercial applications where sealed compressors are used. Employed in systems whose capacity is less than 10 TR with critical charge. Critical charge is the correct amount of refrigerant which will be filled in the evaporator up to its brim level. It will ensure that the liquid refrigerant is not overflowing. And this is used for applications in milk chilling plants and water cooler applications. One information I would like to add, though, which I forgot to add when we are discussing about the capillary tube. In capillary tube, there are two types of pressure drop takes place. One is frictional pressure drop, that is the pressure drop due to friction. The fluid has to overcome the resistance offered by the walls of the tube. And the second one is the momentum pressure drop, that is due to the acceleration of the liquid which is flashed into, some of the liquid is flashed into vapor. So, those two type of the pressure drops are there. Let us move to the third type of the expansion device, thermostatic expansion valve. If you see the constructions, more or less it is similar to the automatic expansion valve. However, here you will see, here also there is a needle stand, orifice is there, capillary tube. There is a feeler bulb, there is a bulb which is used to sense the temperature, that is the degree of superheat. It is attached with the help of a capillary or a narrow tube. This tube is also filled with a liquid that is called power fluid. This tube is filled with a liquid that is called power fluid. It can be a different liquid or it could be the same refrigerant which is employed in the system. So, here the refrigerant is coming out as liquid, and this is the high pressure liquid refrigerant from condenser, and this is low pressure liquid refrigerant to the evaporator. So there are, this is the to the evaporator. So similar to the automatic expansion device, here also we have got diaphragm or bellows. That's a needle stand. Spring is there. Okay, so this is like an adjustment spring. This is like an adjustment spring. So let me repeat here. This tube contains, this tube which is the capillary tube or a narrow tube, it contains a power fluid which could be either the refrigerant which is used in the system or it could be some other. So the main purpose of the thermostatic expansion device, this is normally employed in most of the devices, almost all the devices. It is used to maintain a constant degree of superheat. Maintain a constant degree of superheat in the evaporator. And how that degree of superheat is sensed? It is sensed by a, it is monitored by a sensing bulb. Sensing bulb. It is called a feeler bulb. It is called a feeler bulb. So here the refrigerant vapor is superheated at the compressor inlet, which prevents clogging issues. Where if we don't have superheated condition, what happens? If the evaporator is a flooded type, so the chances of liquid refrigerant due to its accumulation, it will flow out of it the brim, and assuming if critical charge is not there, it will overflow and there are chances of liquid refrigerant entering the compressor, and which will result in slugging issues, which will result in slugging issues. So I think this is slugging issues in the compressor. That is, slugging in the compressor refers to liquid refrigerant entering the compressor. Now let us see, if you see the diagram, there are three forces. One is the evaporator pressure, which is acting on the downward direction. Force due to the adjustable spring, I have just mentioned spring, and the force due to the bellows or diaphragm. The force due to follow-up spring is not shown on the diagram. Doesn't mean that it is not there. It is negligible. It is negligible compared to the force, the same force which is there in the automatic expansion valve. So let us see forces acting on thermostatic extension valve is TEV. So one is the force pressure due to bellows, or diaphragm, that is PB. Evaporator pressure, PE, pressure due to spring, that is the adjustable spring, PS. So PB, PE, PS. If you see the diagram, PB, PE and PS, three forces are there. Of course, the force due to pressure due to follow, this is like adjustment spring. This is adjustment spring. Due to follow-up spring, negligible in TEV. So this feeler bulb is used to monitor the degree of the superheat. So it is used to, as I mentioned here, it is monitored by a sensing bulb, the degree of superheat. So let us see what happens when the load increases. When the load increases, the rate of evaporation will increase. Evaporation rate will increase. If the rate of evaporation increases, the area available for superheating also will increase. Increases. So, which will increase the degree of superheat. Degree of superheat will, when the degree of superheat increases, TB increases, which will increase pressure acting due to the bellows. And if we see the forces, since PB is increasing, it will be greater than the sum of the spring force, that is adjacent spring force, and the evaporator. So, the needle will be away from the usual position, the valve will open, therefore, the refrigerant mass flow rate will, more refrigerant will be circulated. When the load decreases, evaporation rate will decrease. Area available for superheating reduces, which will reduce the degree of superheat. And due to this, pressure acting exerted on the bellows will decrease. If PB is decreasing, then PB will be less than the sum of the other two forces, so which will reduce the mass load of the refrigerant. Thermostatic expansion valve is maintaining a constant degree of superheat. What is this external equalizer, TEV? So, here if you see the diagram, the evaporator pressure is fed, is acting from the downward direction. It is acting on the bellows in the downward direction. Suppose if this evaporator pressure is fed to the bottom portion of the bellows with the help of a narrow tube, then that type of thermostatic expansion valve is called TEV with external equalizer. That is what is shown here. So, if that TEV is fitted, if the evaporator pressure is fed to the bellows or the diaphragm with the help of a tube which is acting in the bottom portion of the bellows, then it is called TEV with external equalizer. Otherwise, it is called TEV with internal equalizer. And similarly, if the power fluid which is used is different from the refrigerant, then such a device is called thermostatic expansion valve TEV with cross charge. PB will be here. In the second case, the equation will be like the reverse. PB will be less than PE plus PS. PE plus. So, this is the commonly employed expansion device in all type of systems. It is expensive. It is not economical compared to capillary device, tube or automatic expansion valve. Better control of system capacity. Starving issues are not there. Slugging issues in the compressor are not there. It protects the compressor from slugging. Let me change this one. Flooding issues are not there. It protects the compressor from slugging. Okay, that is liquid there is not overflow of liquid refrigerant from the evaporator to the compressor. It is not economical compared to AE, automatic expansion, because it is expensive. Care has to be taken during installation. Let us move to the next one, float wall. There are two types of float wall. One is high side float wall, another one is low side float wall. If the float wall is maintaining the liquid refrigerant at a constant level in the condenser, it is called high side float wall. And if the float wall is maintaining the liquid level constant in the evaporator, then it is called low side float wall, because condenser refers to the high side and evaporator refers to the low side. So here the concept is very simple. When the load increases, the evaporation rate of refrigerant increases. So in the evaporator, there will be shortage of refrigerant. So this is the high side from the condenser. It is the high side float chamber. Once the liquid level in the evaporator drops due to faster evaporation rate, the valve will open and the liquid refrigerant will be supplied to the evaporator according to the requirement. And similarly, when the load decreases, the rate of evaporation comes down. So the amount of, according to the level of liquid in the evaporator, the valve will close. It will less amount of liquid according to, because the rate of evaporation is lower. So there is sufficient quantity of liquid refrigerant in the evaporator. So the valve opening and valve closing is according to the rate of evaporation and the amount of liquid refrigerant present in the evaporator. So when the load decreases, the evaporation thereby increasing the liquid level. Float valve opens, allowing more refrigerant from high side to meet the load requirement. It is employed for direct expansion system and flooded evaporator. Normally, this thermostatic expansion valve, it is normally used for dry type of evaporators where there is no flooding issues are there. So let us move to the last type, that is electronic expansion valve. So here you will see one heater, which is, there's a voltmeter, current is flowing, and there's a liquid sensing thermistor. This is the refrigerant. Yeah, needle moves up and down. So this is a needle which moves in the upward as well as in the downward direction. This is the refrigerant which is coming from the high pressure side, that is from the condenser, high pressure liquid refrigerant. This is the electronic expansion valve, and after expansion, the liquid refrigerant, low pressure liquid refrigerant, comes out from in this direction. So if you see this one, so there is a heating element. Let us see the salient features of the electronic expansion valve. So as I said before, there is a needle which moves up and down. The needle moves up and down in response to the magnitude of the current in the heating element. So a small resistance allows more current to flow through the heater of the expansion valve. So there is the heater is there. Expansion. As a result, the valve opens. So instead of a heater, a stepper motor can be used to replace the heater in order to operate the valves, that is to make the valves open and close. That version of electronic expansion valve is also available. This is about the expansion devices. So in the part 1 and part 2 lecture, we have seen the different types of expansion devices like capillary tube, automatic expansion valve, thermostatic expansion valve, high side float valve. The low side float valve is nothing but the float valve which maintains constant liquid level in the evaporator. High side liquid float valve maintains constant liquid level on the high pressure side, which is the condenser. And then we have seen the electronic expansion valve. So I will stop at this point. I will be continuing this in the next lecture. Thank you.